Hello and welcome to my video explaining how to create your own Snake game. In this video I will go through the key parts that make up the Snake and how you can use the same game mechanics however you see fit. So I've created a little game using the Snake game mechanics here for you to have a look at the source code. I will leave a link for that in the description below, and I will also show the graphics for it. Then at the end of the video I will talk about a Snake game that I have created for the Game Boy and uploaded on itch.io for you to check out. So first off, let's look at the key parts when we wish to create a snake in one of these games. So the whole structure of the snake is basically like an array of segments. So each segment, whether it's the head, body or the tail, needs these key parts. So on the Game Boy everything is tile based except for sprites, of course. In the game that I've made there are no sprites in there, as the sprites on the Game Boy are limited to 10 in any horizontal position. That wouldn't cut it for the whole sort of snake dynamics, as there would be far few pieces of the snake to make the game of any real sort of use. So each part of the snake contains these key sort of segments, if you like. So we have a horizontal and a vertical position here, the tile X and tile Y of the segment on the screen. We then need to record what direction the segment is facing, whether it's facing up, left, down or right. And then we also need 3 other key variables to hold the previous tile position and the previous direction that the segment was facing. Now we would normally store these in a kind of list or an array. With regard to the Game Boy, it will purely be a simple array that you would store all your segments in. So one of the key things we need as well is to decide what is the length the snake can actually grow to. This is a key factor on various consoles and old 8-bit machines, as the machines are limited to the amount of memory that they have. So what I'll show you now is I'll go through the graphics for our game. So this will kind of help clear things up as well. Just set this up. So we've got a war tile, which I haven't used here. Then we have 4 images for our snake's head, with facing up, facing right, facing down and facing left. And then we have exactly the same for the body segments, and then the same for the tail segments. And then we have our apple, which are FruitSnake, which is the name of the game by the way, eats. And then we have a splat character for if he eats one of his own body segments. And then we have a faux character set here for displaying text if we need to. I also have a double height set of numbers here as well for displaying our score. I will include these images as well for you to use in your own projects. So I'll now quickly preview the game so you can see what it is. So I'll just restart this a minute. So simple enough, the game is kind of pretty much based on the Nokia Snake game, where your aim is to just get the highest score as you can. As you increase in size, the speed will also decrease between updates, so you will speed up. You need to get over 100 points to be able to get a high score. So this is the key snake mechanics going on here. So the head is always segment 0, and then the tail is always the last segment in the list. So I'll get out of this now, and then I'll jump into code blocks and show you what we're doing. Right, so to better explain all of this now, so what I'll do is I'll split the code window here so we can see a few different things at once here. So the maximum size that the snake can grow to is 255. And then we have a simple anonymous enumeration here. Basically these just set facing up to 0, right as 1, down as 2 and left is 3. These are the only directions the snake can actually travel in. And then we have this structure here, which is our blueprint for our snake. We have the X and Y tile positions, the ode tile positions, what direction we're currently facing, and the direction that the segment was facing previously. So I will now go through how our snake is made up. So these are the two states that our snake can be in. So you can think of the code here as kind of a blueprint for a snake. So we have a variable here which holds how large our snake currently is. And then we have an array of segments initialized to the maximum size here. And then we have another variable here which is just holding what state our snake is in. So if the state is 1, then the snake is alive, otherwise the snake is dead. So this is pretty simple here to get our snake going. So inside the module here for our snake, we have a segment pointer for quick use, and then this isn't really used, to be honest. This is just reflecting what's here. So when we initialize our snake. So we always start the snake in the center of the screen when the game starts. So segment 0 is always the head. I have created these here, but they're not really used in the Game Boy version here. This code was kind of copied across from another version that I have of the game, so these are kind of redundant. So we then set the facing to a random direction. So by putting in this here, so if you notice here we had the facing max here, so we can use that to plug into the random number generator here to give us a random number between 0 and 3, which gives us a starting direction. We then set our snake size to 1, and then we set our snake state to alive, and then we draw the snake head. And another good thing about having facing be between 0 and 3 is we can just add that to the tile. So if I go back to this, so it always makes sense to organize the graphics in this fashion for the snakes as well. So you can think of this as tile 0, that's tile 1, tile 2 and tile 3. So this fits in with facing up, right, down and left. And that fits for all the other snake segment parts as well. So this also gives us a quick way to use facing to draw the correct tile part. So this draws the head, and then in our update function here we check to see if the snake is alive, otherwise we don't want to move the snake here. So another key thing as well with the update method is it's obviously not called very frequently. We limit how many times this is called by tying it to like a game timer to limit the speed, but I'll get to that in a bit. So we have two functions in here, move head and then move body. We always call the move head first because all of the segments, if I bring this up here, they're all linked together. So the body part here is using the old X and Y position of the head, and the tail is using the old X and Y position of the segment body part in front of it. So we're going to move the head first. So we use some temporary variables in here to hold the key parts from segment 0. So we take the current facing direction and the X and Y position of the head. We then put those into the old X and Y position. This is before the head actually moves. We then erase the tile where the head is currently. Then we update the position depending on what direction the head is facing. So if the head's facing up, we move it up by 1. And then also the snake actually wraps around the screen, although I didn't show it in the gameplay example there. we have a minimum Y position on the screen, and then if the snake's Y position goes below that, we then wrap it around to the bottom of the screen. So on the Game Boy it's 18 tiles high, so those are numbered from 0 to 17. So if we just give the head the position of 17, then it will wrap around from the top to the bottom. Same with the moving right here. There are 20 tiles horizontally on the Game Boy screen, which are numbered 0 to 19. So if we move to tile 20, then we need to put it back to 0 for it to wrap around on the left hand side. And then the same with the moving down. Now, moving left will look a bit weird. So as the numbers are unsigned numbers, they wrap around. So if you go past 0 on an unsigned 8-bit number, it will not become a minus number. Instead, it will wrap around to 255. So if the X position becomes 255, we know it's gone off the screen and wrapped around. So we then put it to 19. So that sorts the head out there. So then once the head is moved, we then need to check what tile on the screen is underneath it. So we store that in a global variable which is defined called t. So if t is greater than 0, then that means there is something other than an empty space beneath the head. Now if I bring this back again, you'll see that all of the snake parts are less than the apple character here. So these tiles are, that's tile 0 and that's tile 15. So the apple tile is 14. So all of the snake parts, the tile ID is less than that of the apple. So if it's less than that of the apple, then that means the snake has crashed into itself. So we then need to initialize the death routine for the snake. So we instead of drawing the snake's head, which happens down here, we instead draw a splat tile for the snake's head, then play a sound effect for the snake dying, and then set the snake state to dead, and then return. Otherwise, we draw the snake's head at its new position, and then we put X and Y back into the head segment. We then do a quick check to see whether the tile is greater than 0. As we know, if we've got past this part of the code here and the tile is greater than 0, then we know that we've eaten an apple. So we then call the snake grow function and then play a sound effect for eating the apple. Now I'll go through the snake grow thing here. So all we need to do to get the snake to grow is we need to get the current size of the snake, we then copy that into another variable j. So I and j are global variables that we use throughout the code. We then subtract 1 from j. So if we think of the head as being segment 0, then I is the maximum size, or the size that the snake currently is. So when we first eat the apple, our size is 1. So when we first jump in here, the current size is put into I. J then copies that value and subtracts 1 from it. So that then points to the previous segment, or it will be used to indicate the previous segment. Then what we do is we take the old X position and the current X position of the new segment, and then we set that to the old X position of the segment before it. So for example, if I equals 1, J equals 0. So J is pointing at the head in this case. So we take the old position of the head and copy it into the position, which in this case would be the tail. Then we do the same thing for the facing direction as well. In fact, that should be old facing. Although in fact it doesn't really matter because it won't be updated at this point. So once we've got the new positions for our next segment, then we can increase the size. So that's how you grow the snake. You basically copy the previous segment's old position. In fact, we will put that back to... in fact, that doesn't really matter there, to be honest. I'm not sure whether old facing really makes a difference in there or not. But anyway, we basically copied the old position and facing direction into our new segment. So when it gets drawn, it will appear to be at the old position of the previous segment. And then the move body part here kind of reiterates over everything I just said there. So in the move body part here, we have some temporary variables in this function to use. The reason why we're using these is it's quicker to copy the variables out of the arrays into these temporary variables to work with and then copy them back in, rather than working on the arrays each time, as is stated in the GBDK documentation. It helps the compiler to work quicker. And then we basically create a do while loop here. So we set I to 1 at the start here, so this would be the first segment. Also note that if the size equals 1, then no further action is taken, as we obviously start off with size 1, so this function will return if there's only the head. So then we set J to 0 here, so that is the segment before it. And then at the start here, we take the X, Y and facing position of our first segment here in I. We then copy these to the old parts of the segment. Then what we do is we get the old X and Y positions of the segment previous to I, and copy those positions into the segment's current position in I. Now we need this temporary last variable here to hold the size -1, as the last segment in the list is always the tail, which is the this part here. So this is the drawing part here. This is the part where we move the segment by copying the position of the segment previous. Then what we do is we use the facing variable that we've got here in F to tag on to the tile we want to draw here. So we've got the tail plus facing will give us the correct orientation for the tail. If it's not the last, then we do the same with the body. We then update I and J, and then we check to see whether I is smaller than the size of the snake. If it is, then we go back through and pick up the next link in the chain of the snake, and then copy the segment parts over again. So we always kind of go in order of the snake parts, if you like. So the head is 0. We don't touch that in the move body part. We always start at segment 1, which is after the head. And then J always points at the start to the head. Hopefully that kind of makes sense. And then once we get out of the while loop here, we then get the last segment's old X and Y position, and then we clear the tile there. So we erase where the tail used to be to prevent it from creating like a trail effect. Now we can change the old facing of the head here. And that there is the key parts of the snake movement mechanic there. You'll probably have to, if you're not familiar with it, then you'll probably have to a play around with the code here, like to get to grips with it. There's quite a bit you could kind of do with the snake mechanic. If you think about it, you could create like it doesn't have to be a snake. It could be a caterpillar, a worm. Could even be like a trail of fire behind like a car or a bike or something like that. It obviously depends how creative you want to kind of get with it. And then the other sort of part which is vital here is the turning of the head for the snake. This is called outside of everything else. So we can sort of turn the head of a snake whenever we want. Notice in here we're not recording the old position that we were facing. This is only done at the end of the movement here, and that's the key mechanic here for the snake movement. Don't think there's anything to save there, like. So the rest of the code pretty much is the same as most of the other sort of Game Boy videos here. I'll quickly go over a few things just to square things away if you've not seen it in my previous videos. So the key parts here, the high score, you need 100 points to get onto the high score, or rather to have your high score appear on the title screen. I think most of the code for this is pretty clean. It's I think I've laid it out fine here. Let me know if you find any of it confusing, or you think I should adopt some other sort of form to explain it more clearly. So the two main parts here, we have the main game state, or the main program state if you like, and then we have the core functions into the game. These are the two sort of main variables. The main state, which is either title screen initialize or title screen run, or game initialize, game run. I think these are probably the main sort of parts of any game, really, is to kind of split it into key states which are cleanly separated from one another to make working with these individual parts easy and clean. That way it allows you to move the code across to other consoles or platforms. It doesn't even have to be C. You could take it to whatever else you like, Java, C#, JavaScript even. The key sort of fundamentals are the same. So in our main function here, first initialize the graphics, but there's not a lot in here. We have our tiles, our main tile set, which is this one here, and then we have our double height numbers, which is these ones here. I have my graphic define header file here to allow me to easily distinguish where the key tiles are. So I always have this sort of layout here. So we have graphic tile start, then the name of those tiles. We always record the number so we can use that to easily get to the next position in memory where the next tiles need to go. Then after these, we then create some simple defines to say where the tiles are, and hopefully give a meaningful name as well, so it allows us to quickly use these tile numbers without having to remember the numbers. And then in this function here is where the graphics for the tiles live. So one additional thing I've put in here is fade in and fade out functions here, which works well in the Game Boy here. So there is a register that handles the palette values for the Game Boy. It does actually have 4 distinct colours, if you like, or rather shades, you can think of them. So I'll go down and quickly go over that. So this one here, background palette register. So there's 2 parts to the fade in and the fade out here. I mean, the way that I found to organise the games on the Game Boy is to always have the bright colour as the background colour, kind of the default if you like, and then have the colours in this sort of order here. So white, light grey, dark grey and black. So when you call fade out, it uses a loop here and a switch statement to gradually fade the colours all to black, which is what happens here. So you start off gradually darkening them out, and then you pass in a delay, how long you want between each shade change. And then the update delay function just creates a loop where it calls screen synchronize, or screen refresh if you like, just in a for loop here. And then fade in does the opposite there, starts all sort of darkened out, and then ends back to white, light grey, dark grey and black. So it's a useful little fade function there. Everything else is pretty much as I've gone over in the previous videos with the Game Boy, where I've gone through why the various things here exist. So that's pretty much all I want to go through with the code here. Everything is kind of self-explanatory. I'll quickly go over the game bit here. The core sort of game loop, if you like, just quickly. So we have an enumeration here with some game states. Not very many of these are actually used in this game, as the key part is the actual snake. This here is where the score is located, rather the minimum position on the screen to wrap around the Y position for the snake. And this is the game delay, as the game would otherwise move really quickly if you had this too low. Some of these like game mechanics you kind of have to play around with to get just right. I find that this is a decent number to plug into the timer. So in the game itself here, so when the game starts, we clear all tiles from the screen, we initialize the snake. We have some apple functions here, as there's only one apple at a time. It's nice and simple. We have a horizontal and vertical position for our apple. Here's our timer, which we reuse for various parts in the game. And then we have a boolean here saying whether we should draw the score or not. Obviously, if we've not collected an apple, we don't need to draw the score more than once. This sets everything up. We fade in the screen, and then we set the update timer to 64 here, and then play some music. If you're unsure of the music code here, then check out my video on making music and sound on the Game Boy for a better, more in-depth explanation, as I'm not intending to go into any of it in here. And then at the end here, we set the state to game run. This is the main game run loop here with the key states which are in this game. As you can see, it's nice and simple here and nice and clean. Spawn apple just generates a random number between 20 and 15 for, rather 20 for the horizontal, 15 for the vertical, and it then adds the minimum Y position to that, so Y is always in that region. The reason why it's in a do while loop is we first check the tile on the screen at the apple X and Y position to make sure we're not drawing over a snake segment. So if the tile is not 0, then we continue in the while loop. Otherwise, we draw the tile on the screen. Then in tile eaten, all we do is check the apple's X and Y position, get the tile there, and see if it equals an apple. If the apple's still there, then we return false. Otherwise, we play a sound effect for eating an apple, add 5 to the player's score, spawn a new apple, set draw the score to true, and then another key part of the game mechanics here for this game is whenever you eat an apple, we reduce the time it takes to update. So the larger you get, the quicker the game becomes. Here's our draw score function here. So one key thing with this, which I haven't kind of done before, I guess, is you need to pass in where the numbers start, where the first tile for the numbers start, so it can draw the tiles correctly to represent those numbers. Now in the play game function here, which is where the main bits live, we're only reading one key at a time. Obviously we can't move in multiple directions, we can only move in one. So this is where the snake turn function comes in here. If you pressed and released the right button, then we turn right. Same with left, up and down. Now I've left this in as it's something I needed to double check here. So once you've got your key sort of game mechanics into your game, you obviously then need to check that it can do and run as you expect it to. So sometimes you need to quickly iterate or jump to new levels or new states of the game. So this is kind of what this does. I wanted to see that the snake grew properly, and then that the speed obviously changed as I expected it to. Whether -2 to the update time interval was too much or not, it was fine. It was fine. So I have adopted that in here. I've left that there just for you to maybe you want to have a play around with that yourself. See how well you can move a snake around when it's 200 segments or something like that. And then this is the timer function here. So if the update timer has elapsed, then we update the snake. Otherwise we don't touch this, as we don't need to move the snake every update, only occasionally. And then this just will redraw the score if we need to, or grow the snake if we eat an apple. And then the kill player function here, we use the Z substate variable. So the substate is, if you think of like the game state, and then we have a substate within each individual game state. This just allows us to use that function and then split it into separate parts inside of there. So if the substate equals 0 when we call this, then that initializes everything going forward. So all this does is just iterate over each of the parts of the snake and then draw a splat segment, play a splat sound effect, and then notice here we've reused the update timer by changing the amount in here to a moderate time to display the splat tile part for each of the snake segments. Another bit in here as well is this allows us to skip the def part where it draws the splats. So the IN_joy variable, if I get back to showing you some of the global variables here, so we have, these are the main unsigned char variables here. Joy now and joy ode are used for the joypad buttons. Joy now is what button is currently pressed, and joy ode is what was previously pressed. So we're checking that any of the key buttons, like the A button, B button, start or select, are pressed. If they are, then we'll skip over the killing of each of the tile segments there, and then we'll set the game state to game over. And then all game over does is display the game over text. Again, we use the update timer, repurpose it to display game over at a set timing where it only displays one of these letters at a time. The T variable there is used for the horizontal position of the one character that we're displaying here. So this is setting I to the letters game over every time it comes through this part of the game over function here. And then again here we allow the player to skip this. And that pretty much is it for this video. Hopefully you've found this useful and you'll be able to maybe make a snake-like game yourself now. So if you want to check out what you can come up with this, I'll link to the bottom of this a link to my itch.io page where I have a Game Boy Snake game which I have on sale there. So by all means jump over and check that out, as that will show you a more interesting take on the whole sort of snake mechanic there. So I'll leave a link in the description to the video, which will have the source code to the game and the graphics as well. Let me know if you make any snake games using this. So that's it for this video. Thanks for watching.